video, I'm going to be talking about the Wheatstone bridge. The Wheatstone bridge is a circuit setup that is used to measure the value of an unknown resistor, precisely this resistor. So what you do is that you have a ratio arm, these two resistors. Then you insert your unknown resistor. Then after you do that, you vary the value of this resistance until there's no current flowing across the galvanometer. So when you do that, you can replace this galvanometer with an ammeter, and when you do that and you realize that there's no current flowing across the galvanometer, then you can proceed to use this relationship. R1 over R2 equals R over Rs, and this is why this arm is called the ratio arm, because it is the fixed value that I use to compare with this side. So I have a Wheatstone bridge set up here. As you can see, we have the resistor R1 here, resistor R2. This is the standard resistor Rs, and this is the port where I connect the resistance I want to measure. These two terminals are where I connect the ammeter, the galvanometer, but in this case the ammeter. And then this is where we measure the value of the resistance that we vary. As we vary it, then this is where we connect our power supply. So we have a 2 kilo ohm resistor here and an 100 kilo ohm resistor here. So this variable resistor can be varied as far as 10 kilo ohms. I'm going to proceed to set up the Wheatstone bridge as it should be. So I'm going to connect my multimeter. This time is at the ammeter setting. So I'm going to connect it across the terminal. So it's going to be like then I am going to hook up a battery. Hook up a battery to it. So we're going to connect this resistor across. So we're going to vary this potentiometer to reach 0. Oh, we passed it. We have our 0. So we have reached 0 by varying the potentiometer value. It is at this point when the value on the ammeter is 0 that we can say that the Wheatstone bridge is balanced. So the next thing we do is that we measure the resistance across the resistor, the variable resistor, to know the value of the variable resistant. To do this, what we do is we set the multimeter to the ohm meter settings. Then we use this terminal that has been provided to measure the resistance of the potentiometer. So we do it like this, and we get 4.75 kilo ohms as our value, the value of our resistance at that point. We go on ahead to use the expression that I stated earlier on, that R1 over R2 equals R over Rs. You will discover that R1 over R2 which is 2 divided by 100 is 0.02, and then you also discover that R divided by Rs, which is 100 divided by 4750, is equals to 0.021, which is very, very close. So you can see that the relationship actually holds. we'll be trying to determine the value of an unknown resistance using the insight that we get from the Wheatstone bridge. So we connect the resistance across the Wheatstone bridge like this. Okay. So what we do next is that we vary the value of the potentiometer until we hit 0. Okay. To go like this. And then we have 0. That means we have 0 current flowing through the ammeter. Then the next thing we do is that we check the value of the resistance. So we go ahead, we switch this to the ohm meter setting, and then we go ahead to test for the value of the resistance of the variable resistor, and then we get a value of 9.2423 kilo ohms. We know that the ratio R1 over R2, that's 2 over 100, which is also the same thing as 0.02, is equals to the unknown value of the resistor multiplied by the value of the variable resistor, which is 9.3 kilo ohms in this case. So we know that the value of the resistance that we're looking for is 0.02 times 9.23 times 1000. This gives us a value of 185 ohms. But in the past, it must have been used to measure and estimate the value of unknown resistances when we didn't have more accurate instruments for measuring resistances. And these days, the Wheatstone bridge is only used for educational purposes. So thank you for watching my video. See you next time.